First, this is our topology. This is the part, the segment, the public segment that the ISP gave us. This is the client in which they're gonna try to reach the servers, and the servers gonna try, and the users gonna try to reach a server in internet. Let's call it YouTube with this public IP. The VLAN 3 will locate the servers, and the VLAN 5 will locate the users. I have configured the basic connectivity just to save time. The servers are gonna be a router simulating being hosts. In this case, they have their IP address, their mask, and their default route. Then this is the switch config. We disable BTP. We configure the VLANs. This is the interface, the trunk interface to the router. I am using a router on a stick. .1Q. The links to the servers in the respective VLAN. This is the routing configuration. This is the configuration through the ISP. This is the configuration through the switch. I'm using sub interfaces because, as I said, I'm using a router on a stick. And this is the default gateway to the ISP. This is the ISP configuration. This is the config to us. These are the public IPs simulating the servers in internet. And the ISP have our static route with our pool of public IP addresses pointing to us. Well, let's see. First, wanna see static NAT. In this case, the server 1 will use this IP address. All ports will be open. First, we have to define the NAT zones. This is gonna be the outside, and our LAN gonna be the inside. Here I define the outside. This is not necessary because there is no VLAN there configured, so you can ignore this. And this, in our sub interface, there's gonna be the IP NAT inside command. Then we have to configure the NAT. So with this command, I'm telling the router from this private IP address, it's gonna be translated to this public IP address. For example, my source private gonna be translated to my public IP address. This is an static, and I define my inside of the network. So if the server 1 tries to communicate to an IP public IP address, when the packet comes to the router in the inside zone, they're gonna check the source, and they're gonna see, oh, I have a translation 172.16.3.1 to 200.0.0.1. So I'm gonna translate the packet, I'm gonna change the source, and I'm gonna forward the packet. And then when the traffic comes back, the source address, the public server in the internet, to our public address destination. And when the packet arrives to the outside interface, then the router gonna see their configuration about the NATs, and they're gonna see that this public IP address has to be translated to this IP address, private IP address. Then the packet arrives to the server 1. I'm here trying the communication, and as you can see, the communication is successfully. The verification of these things, it's in this place. This parameter is the static NAT. How can I see that all the ports are open? Because there is no ports in this place. Like in this example, this is the communication. Because I was testing ping, the ping used aleatory ports, random ports, so that that were the ports that was using during this communication. Then you can see the statistics of the NAT, the number of packet translator, the failures. Now we're gonna see NAT based on ports. In this case, we're gonna use this configuration in the server 2, and the requirement is the next. Server 2 will use 200.0.0.2 just by the ports TCP 80 and 23. That means all the remaining ports can be used for another hosts in the net or for future openings through this server. The communication will be from outside to outside and vice versa. Let's see an example. Well, first we're gonna define the NAT zones. In this case, we already defined them in the last configuration, but just take it as a reference. Then we're gonna use the configuration. Here I commit the configuration, but it's not displayed here. So this is the full commands. In this case, I'm just gonna opening the ports for this IP address. This is gonna be the ports and I have to use extendable. Extendable means if I'm gonna use more than one IP NAT inside source static command for one IP, I have to use extendable. So in this case, what's gonna happen? For example, let's see one client from internet tries to access to our server web. In this case, this is server 2. So they're gonna use a random source port, and the destination will be this 80 port with this public IP address. When this packet arrives to the outside interface of a router, they're gonna check that it has a translation. So just gonna change the destination IP address, but will remain the same port. So that's why the web solicitude can reach our server. And then our server 2 gonna answer this packet with the source private IP, source port 80, and the destination and the respective port. When the packet arrives to the inside, the router gonna check this part, and they're gonna translate the private IP to the public IP address. Okay. Now, a client in internet tries to reach the FTP port of this public IP address. When the packet arrives to the outside, the router will notice that yes, it has a translation for this public IP address, but not by this port. So the packet will be dropped. Here are some testings. For example, from the client in the topology tries to reach my public IP address termination 2 with the telnet port, and it responds. It answers. Then I try to reach it by the 80 TCP 80 port, and the port answers me. He refuses the connection, but answers it. So the port is open. But if I try to reach it by the 81 port, we see connection timeout. That means the router ignored our petition, meaning that the port is closed. Then I try to reach by ping, and there is no response. Why? Because when we use ping, the communication over the ports are randomly selected. So if you don't use 23 or 84, the communication will be dropped. This is our verification. This thing is the last configuration, so you can ignore it. This is the new configuration. As you can see, those are the opening ports. These things are the configuration, so you can ignore it. There will be always in the NAT table, and that was the communication that we tested before with from this public IP address. Then we see dynamic NAT. We'll see dynamic NAT. Server 2 will use termination 3 and termination 4 addresses. We have to define NAT zones. We have first to create our public IP address pool. In this case, I cannot see all the configuration here, so I'm gonna I displayed here. So we create our NAT pool called dynamic servers, and our pool will have two IP addresses, 0.3 and 0.4, with the MAC address that the service providers gave us. Then we have to create the access list to allow the communication of the private IP address that which want to have the communication to internet, or have the access to the public IP addresses pool. In this case, the access list is a standard called servers, and I'm gonna only allow the server 3 to access to that public IP addressing pool. Then I have to apply the NAT. In this case, all my private IP addresses in this access list can use this pool of public IP addresses. Now I'm going to try the communication. In this case, the server 3 can reach this public IP address, and if we see the translation, we're going to see the ports of communication through to the public IP address. Then we're going to see the pool utilization with the IP NAT statistics. In this case, we have the pool, the mask, and our start address in the pool and the finish IP address in the pool. We have a total of 2 addresses, and now we have allocated 1 IP address. If we implement another server, and server 3 and, for example, server 4 try to communicate, are allowing the access list and try to communicate, the 100% of the IP addresses will be used. And if we add a third server, and all 3 try to communicate to internet and are allowed to access the pool, one of the servers not gonna reach internet because there are just 2 public IP addresses. Finally, we're gonna check NAT path. In this case, the users in our network will reach internet using those public IP addresses. We have to define the NAT zones, and then we have to apply the NAT. In this case, I think I missed. No, this is okay. We're gonna create another public pool. The pool of public IP addresses are gonna called IPs users, and there's only gonna be 2 IP addresses in this pool. We're gonna configure the mask. Then we're gonna create the access list to match all our private IP addresses that we want to reach the internet and reach that pool. In this case, this segment /44. Then we're gonna apply the NAT. In this case, all the users in this access list will allow to use this public pool IP addresses to reach internet. But the most important thing is to make NAT to make NAT to path will be this word overload. This overload means that the public IP address will be divided in all the ports. I think we have a lot of 65,000 and something else ports. So many hosts can use the same public IP address by different ports. In this case, I'm gonna use try communication, and if I see my NAT translation table, I'm gonna check that they use that port to reach internet, vice versa. If we implement another user and we use the same private addressing of the user's VLAN, they're gonna reach internet by the same using the same IP address, but they're gonna use another port, for example, 5000